To determine the UL rating for wire connectors used in direct current DC solar connections, it's important to understand how Underwriters Laboratories UL listing works and how to access relevant information. The UL Electrical Construction Equipment Directory is a key resource, although not publicly available in libraries. You can obtain the necessary information by contacting UL directly. They can be reached by phone at 1-800-227-8000, 573 or via email at. They may be able to provide the information you need either over the phone or through email. Another option is to purchase the UL Electrical Construction Equipment Directory from UL website or from other reputable online retailers. This directory contains detailed information about UL listed products, including wire connectors. When dealing with an electrical inspector and questions about compliance, it is crucial to know where the burden of proof lies. As the electrical inspector, it is generally their responsibility to demonstrate that a violation exists. It is not necessarily your responsibility to prove that the wire connectors are approved for DC solar connections unless there's a clear indication of misuse or misapplication. Ideal Industries, a manufacturer of wire connectors, states that their wire connectors are UL listed for both alternating current, AC, and DC applications. This information can often be found on their website, which can be a useful resource for confirming the suitability of their products. Article 110.3 of the National Electrical Code, NEC, is often cited in these situations. This article requires that electrical equipment be approved for its intended use. UL listing is a widely recognized and accepted form of approval for electrical equipment, demonstrating that it has been tested and meets specific safety standards. Based on this information, here are some recommendations. Firstly, contact UL directly or purchase the UL Electrical Construction Equipment Directory to obtain the specific UL rating for the wire connectors you are using. Secondly, provide this information to the electrical inspector, explaining that the wire connectors are UL listed for both AC and DC applications, and therefore meet the requirements of Article 110.3 of the NEC. Thirdly, if the inspector insists that you must prove the approval, politely inform them that it is generally their responsibility to demonstrate the violation if they believe the installation is not compliant. To further clarify the specific requirements of Article 110.3 of the NEC, it states that equipment shall be installed and used in accordance with any instructions included in the listing or labeling. This means that if the wire connectors are listed for both AC and DC use, and you are using them within the specified voltage and current ratings, you are likely in compliance. Additionally, it is important to ensure that the wire connectors are appropriately sized for the conductors being joined and that they are installed correctly, following the manufacturer's instructions. Factors such as conductor material size and environmental conditions also play a role in ensuring a safe and reliable connection. If the inspector continues to raise concerns, you may consider requesting a written explanation of the specific reasons for their objection, referencing the relevant sections of the NEC or other applicable standards. This can help to clarify the issue and provide a basis for further discussion or appeal if necessary. Furthermore, keep in mind that electrical codes and standards can vary depending on the jurisdiction, so it is always a good idea to consult with local authorities or a qualified electrical engineer to ensure full compliance with all applicable regulations. Remember to document all communications with the inspector and any evidence of product listings or approvals. This documentation can be valuable in resolving any disputes and demonstrating your commitment to safety and code compliance. In summary, understanding the UL listing process, knowing your rights and responsibilities as an installer, and effectively communicating with the electrical inspector are all essential for ensuring a smooth and compliant installation. By following these steps, you can address concerns about wire connector ratings for DC solar connections and maintain a safe and code-compliant electrical system. It's also worth noting that UL website often provides access to white papers and other technical documents that can further clarify the requirements for electrical equipment used in specific applications, such as solar power systems. These resources can be helpful in understanding the nuances of UL listing and demonstrating compliance to inspectors. Moreover, consider joining professional organizations or attending industry events related to electrical construction and solar energy. These forums provide opportunities to learn about best practices, stay up to date on code changes, and network with other professionals who can offer valuable insights and advice. By continuously expanding your knowledge and staying informed about industry developments, you can enhance your credibility and ensure that your installations meet the highest standards of safety and performance. Finally, remember that electrical inspections are intended to ensure the safety of electrical systems and protect people and property from hazards. While disagreements may arise from time to time, it is important to approach these situations with professionalism and a willingness to work collaboratively to find solutions that meet both the requirements of the code and the needs of the installation. In the context of wire connectors for DC solar connections, it is important to delve deeper into the specific UL standards that apply and the performance requirements that these connectors must meet. Wire connectors used in photovoltaic (PV) systems are typically subjected to rigorous testing to ensure their reliability and durability under harsh environmental conditions, including exposure to sunlight, temperature extremes, and moisture. UL 486-486B covers safety for wire connectors for use with copper conductors, and UL 486C covers safety for splicing wire connectors. These standards outline the construction, performance, and marking requirements for wire connectors intended for general use in electrical systems. However, additional requirements may apply to wire connectors specifically designed for use in PV systems, such as those outlined in UL 6703, which covers connectors for use in PV systems. UL 6703 specifies requirements for connectors used to make electrical connections within PV modules, arrays, and systems, including requirements for environmental resistance, mechanical strength, and electrical performance. Wire connectors that comply with UL 6703 are marked with a PV designation, indicating that they are suitable for use in PV applications. When selecting wire connectors for DC solar connections, it is important to ensure that they are not only UL listed but also specifically evaluated and listed for use in PV systems, as indicated by the PV designation. This ensures that the connectors have been subjected to the additional testing and evaluation required for these demanding applications. In addition to UL listing, wire connectors used in PV systems must also comply with the requirements of the NEC, which provides specific guidance on the installation of electrical equipment in PV systems. Article 690 of the NEC covers solar photovoltaic systems, including requirements for wiring methods, overcurrent protection, grounding, and disconnecting means. Section 690.4d of the NEC addresses the use of wiring methods and equipment within PV systems, requiring that they be identified and listed for use in PV systems. This reinforces the importance of selecting wire connectors that are specifically designed and listed for PV applications. Furthermore, the NEC provides guidance on the proper sizing and installation of wire connectors, taking into account factors such as conductor size, ampacity, and temperature rating. It is essential to follow these guidelines to ensure that the wire connectors are properly installed and can safely carry the current and voltage levels present in the PV system. In addition to compliance with UL standards and the NEC, it is also important to consider the specific environmental conditions in which the wire connectors will be used. PV systems are often installed in outdoor environments where they are exposed to extreme temperatures, sunlight, and moisture. Wire connectors used in these applications must be able to withstand these harsh conditions without degrading or failing. Therefore, it is important to select wire connectors that are specifically designed for outdoor use and are made from materials that are resistant to UV radiation, moisture, and corrosion. In summary, selecting the appropriate wire connectors for DC solar connections requires careful consideration of UL standards, NEC requirements, and environmental conditions. By choosing wire connectors that are specifically designed and listed for use in PV systems, and by following the manufacturer's instructions and the NEC guidelines for installation, you can ensure a safe, reliable, and code-compliant PV system. When discussing wire connector applications in direct current DC Solar connections, several key electrical parameters and safety considerations come into play. These factors are crucial for ensuring the long-term reliability and safety of photovoltaic (PV) systems. Firstly, the voltage rating of the wire connector is paramount. In DC solar circuits, voltages can range from relatively low levels in residential systems, such as 24 volts or 48 volts, to much higher levels in commercial or utility-scale installations, potentially reaching 600 volts or even 1000 volts. It is imperative that the wire connector is rated for at least the maximum voltage expected in the circuit. Using a connector with an insufficient voltage rating can lead to insulation breakdown, arcing, and ultimately electrical failure and fire hazards. Secondly, the current rating of the wire connector must be carefully considered. The current flowing through a DC solar circuit is determined by the power output of the PV array and the system voltage. Wire connectors must be sized appropriately to handle the maximum continuous current that is expected to flow through the circuit. Overloading a wire connector can cause excessive heat buildup, leading to degradation of the connector materials, increased resistance, and potential failure. The NEC provides guidance on conductor ampacity and wire connector sizing to ensure that conductors and connectors are adequately rated for the intended current. Thirdly, the operating temperature range of the wire connector is a critical factor in PV applications. Solar installations are often exposed to extreme temperatures, particularly in hot climates. Wire connectors must be able to withstand these high temperatures without degrading or losing their electrical or mechanical properties. Connectors that are not rated for high temperature operation may become brittle, crack, or lose their grip on the conductors, leading to connection failures. Fourthly, environmental protection is essential for wire connectors used in outdoor PV installations. Connectors should be resistant to moisture, UV radiation, and other environmental factors that can degrade their performance over time. Connectors that are exposed to moisture can experience corrosion, which increases resistance and reduces the current carrying capacity. UV radiation can cause the connector materials to become brittle and crack, compromising their mechanical strength and insulation properties. Fifthly, the type of conductor material used in the PV system must be compatible with the wire connector. PV systems typically use copper conductors, but aluminum conductors may also be used in some applications. It is important to select wire connectors that are specifically listed and approved for use with the type of conductor being used in the system. Using incompatible connectors can lead to galvanic corrosion, which can degrade the connection over time. Sixthly, proper installation practices are crucial for ensuring the long-term reliability of wire connectors and PV systems. Connectors should be installed according to the manufacturer's instructions, using the correct tools and techniques. Over-tightening or under-tightening connectors can damage the conductors or the connector itself, leading to connection failures. Seventhly, periodic inspection and maintenance of wire connectors are important for identifying and addressing potential problems before they lead to system failures. Connectors should be visually inspected for signs of corrosion, damage, or loose connections. If any problems are detected, the connectors should be replaced immediately. In summary, selecting and installing wire connectors for DC solar connections requires careful attention to voltage rating, current rating, operating temperature range, environmental protection, conductor material compatibility, proper installation practices, and periodic inspection and maintenance. By following these guidelines, you can ensure the long-term reliability and safety of PV systems. When addressing the UL listing of wire connectors specifically for direct current DC applications, it's essential to understand the nuances of how Underwriters Laboratories all tests and certifies these components. While many wire connectors are listed for both alternating current, AC, and DC use, the specific tests and performance criteria may differ depending on the intended application and the relevant UL standard. Firstly, UL 486-486b, the standard for wire connectors for use with copper conductors, includes tests to evaluate the electrical, mechanical, and environmental performance of wire connectors. These tests include, but are not limited to, voltage drop tests, temperature rise tests, pull-out tests, and corrosion resistance tests. For DC applications, UL may conduct additional tests to evaluate the connector's performance under sustained DC voltage and current conditions. These tests may include long-term aging tests to assess the connector's ability to withstand the effects of electrolysis and other phenomena that can occur under DC conditions. Secondly, UL 486C, the standard for splicing wire connectors, covers connectors used to join two or more conductors together. This standard includes similar tests to UL 486A-486B, but with a focus on the performance of the splice connection. For DC applications, UL may conduct additional tests to evaluate the splice connector's ability to maintain a reliable electrical connection under sustained DC voltage and current conditions. Thirdly, UL 6703, the standard for connectors for use in photovoltaic PV systems, includes specific requirements for connectors used in DC solar applications. This standard includes tests to evaluate the connector's resistance to UV radiation, moisture, and other environmental factors that are common in outdoor PV installations. Connectors that comply with UL 6703 are marked with a PV designation, indicating that they are suitable for use in PV applications. When evaluating the UL listing of wire connectors for DC applications, it is important to look for the specific UL standard that the connector complies with and to verify that the connector is marked with the appropriate designations, such as PV for PV applications. It is also important to consult the manufacturer's specifications to determine the connector's voltage rating, current rating, and operating temperature range. In addition to UL listing, it is important to consider other factors when selecting wire connectors for DC applications, such as the type of conductor being used, the environmental conditions, and the installation practices. Using the wrong type of connector or installing it incorrectly can lead to connection failures, which can have serious consequences in DC systems. In summary, the UL listing of wire connectors for DC applications involves specific tests and performance criteria to ensure that the connectors can withstand the unique challenges of DC systems. By understanding the relevant UL standards, verifying the connector's markings, and considering other factors such as conductor type and environmental conditions, you can select the right wire connectors for your DC application.